Welcome to Sky Activation in Footscray, a climate change design response to combat urban heat island effect by reducing urban canyon. Our research was based on the structural plan for Footscray, and we specifically focused on precincts 2 and 5, described in this document. These precincts are relevant because they have been targeted for vertical development and are already being built up in an unrestricted manner. This was evident on our site visit, where we could witness the problems regarding sun access and overshadowing, as well as a tendency to canyons to develop, which might become a problem regarding climate change. This, along with other existing conditions such as prevalent car-focused design and poor pedestrian connectivity, make the site a non-place for locals, which, if left uncontrolled, put Footscray at risk of becoming a low-quality urban space. The whole suburb houses a population of 17,000 people, and historically this land was part of the Kulin Nation. As mentioned before, the chosen areas are undergoing a transformational change as directed by the Council's planning scheme, which includes a new building height limit up to 25 stories. In order to future-proof our design, the Aboriginal aspects of individual, interpersonal, organization, community, and society values have been considered for the development of our design solution. The poor existing conditions may have become aggravated by the future climate conditions relevant to the larger Victorian context, and specifically in Melbourne, where temperatures are predicted to rise by 6 degrees on average. Under these new climatic conditions, we are at risk of severe heat waves becoming common occurrences. This problem is more common in urban areas where urban heat island effect and urban canyon are prevalent due to building shape and materials. Urban canyon is when tall buildings trap warm air, reducing natural cooling breezes in urban conditions. A method to quantify this is by measuring the sky view factor, or SVF, of an area, which reflects how much canyons are created in urban areas. This SBF is affected by the building shapes and layout, and this is what we're using to develop a solution. The design exploration uses blocks in a 3x3 grid. The next two iterations introduce height variation of the buildings whilst maintaining the volume in the area. For the second iteration, introduces a 3-meter setback as well as height variations. The third generation continues uses a podium, but the setback is set as 5 meters. The result in higher buildings to maintain the same volume. The same changes were made for buildings with circular bases, both for the podium and the towers, with a diversity of heights and setbacks. Then, this was repeated for a building with a 12-sided polygon base. The result was modified to have different heights while maintaining the same volume. The final iteration is a building with an octagonal base with rotation every other floor. Setbacks and building heights were changed. These were the results of the SBF analysis. For the square-shaped buildings, the basic shape with no setbacks performed the worst, while the version with 5-meter setbacks performed the best. For the circle-shaped buildings, the basic round shape performed the worst, and as the previous test, 5-meter setback and height variation was the best. The 12-sided building performed differently, as the 3-meter double setback and height variation performed the best. The final shape was an octagonal plan that was rotated every other floor. The overall results were considerably better than the square shape and more like the circular shape. The best version of this was the 5-meter setback with height variation. This last one was considered the most successful shape, and it was used to develop new iterations that focus on modifying the original square podium. The shapes derived from modifying the square by chamfering and curving its edges. The chamfers are 2.5 and 5 meters, and the curve is 5 meters. When analyzed, the best performance was a curving edge podium with setback. This shape was then chosen as our ideal building form to be applied on the existing sites. The buildings were implemented in the chosen 2 and 5 precincts as a guideline to the new development to ensure design response that maintain high-quality pedestrian-level conditions. To understand and compare our design response, the maximum envelope was modeled, and over it our new buildings formed were introduced to analyze their performance to reduce urban canyon effect. It is clear that there was a significant improvement in terms of SBF levels, which means a reduction in the canyon effect for future development by following these new design guidelines. Overall, we attempt to improve the heat control in the area at street level whilst creating a rich urban experience with enhanced walkability, floor level activity, and accessibility to ground level activities.